41 feet below a condemned parking garage on Congress Street in Portland, Maine, there's a room that shouldn't exist. Running water, heat that holds through the night, a floor so level you could set a marble on one end and it wouldn't roll. Dry walls, ceiling that doesn't leak. The woman who built all of it never finished high school. Her name is Harlow Janney. She's 44. She has strawberry blonde hair chopped uneven at the jaw, a widow's peak going silver, and a gap between her front teeth she never bothered fixing. There's a vertical scar through her right eyebrow from a car accident in 2017, a faded anchor tattoo on her left collarbone from a boyfriend she doesn't talk about, and hazel green eyes that look gold in certain light. She walks with a slight limp on her right side. Her hands are square, and her nails are always dirty. When a structural engineer named Paul Witham crawled through the access point in March of 2024 after an anonymous tip, he expected to find a squatter's nest. Blankets, maybe. A propane burner. Some milk crates. He found a 2-room apartment with load-bearing walls. That should be the end of the story. It's not. And the reason it's not is what makes this whole thing hard to shake. What Harlow built in that basement breaks about 6 assumptions you probably have right now about what's possible, with no money, no training, and no permission. The deeper you look at what she did down there, the less any of those assumptions hold up. Picture what you'd expect to find. A homeless woman finds a hole in the ground. She moves in. She sleeps there. Maybe she hangs a tarp. Maybe she drags in a mattress from somewhere. That's the version your brain assembles when you hear a story like this, and nobody would blame you for it. The shelters in Portland were full in the winter of 2022. The waiting list for Section 8 was 19 months. Harlow had been sleeping in her car, a 2003 Subaru Outback with a cracked windshield and a heater that worked about half the time, parked behind a Rite Aid on Forest Avenue. She found the basement by accident. October 2022, first hard frost of the season. She was walking along the backside of a condemned parking structure off Congress Street, the one that had been chained off since 2019 after a water main break corroded the foundation supports. She wasn't looking for shelter. She was looking for a place to charge her phone. There was a construction power panel on the east wall that she'd heard still had juice, but behind a collapsed section of chain-link fence, behind a dumpster full of ceiling tiles and bent rebar, she found something else. A concrete stairwell going down. No door. The door had been removed during the demolition prep that never happened. Just a rectangle of darkness and a smell like wet stone. She went down. 41 steps. She counted them. The basement was the mechanical room for the parking garage, and it had been sealed off when the building was condemned. 2 rooms, one large, about 20 by 30 feet, and one smaller room off to the side, maybe 8 by 12, poured concrete floor, cinder block walls, ceiling height of 9 feet, which is more than most apartments. No windows, obviously, one dead fluorescent fixture hanging from the ceiling by a wire. The air was cool, not cold. Even with the October frost topside, the basement sat at about 55 degrees. Harlow didn't know the term thermal mass at the time. She didn't know that 41 feet of earth and concrete acts like a battery that stores the average annual ground temperature and releases it slowly through the walls. She just knew it felt warmer than her car. She slept there that night on a moving blanket she'd been keeping in the Subaru, and she came back the next night, and the next. If the story stopped there, it would be ordinary. Sad, maybe. Expected. Homeless woman, hole in the ground, blanket on concrete. It didn't stop there. By the second week, Harlow had a problem she hadn't expected. Water, not a flood, something worse in a way. Condensation. The walls were sweating. Moisture from her breath and her body heat was collecting on the cold cinder blocks and running down to the floor in thin sheets. Her blankets were damp by morning. Her clothes smelled like mildew. The concrete floor was slick in certain spots. Most people in Harlow's position would have done one of 2 things: left or ignored it. She did neither. She went to the Portland Public Library on Monument Square. She sat at a computer terminal for 3 hours, and she looked up basement waterproofing. Not how to stay dry in a basement. She typed basement waterproofing commercial methods and condensation control below grade, and vapor barrier installation. She read a PDF from a company called Tremco that manufactures commercial waterproofing systems. She read half of a Home Depot installation guide for interior drainage matting. She read a forum post on a home building site where a contractor named Rick from Bangor was arguing with another contractor named Dave from New Hampshire about whether you should put the vapor barrier on the warm side or the cold side of an insulated wall. Rick was right, by the way. Warm side. Harlow figured that out on her own after reading both arguments. Over the next 2 weeks, she collected materials. Specifically, 4 rolls of 6mm polyethylene sheeting from a construction dumpster behind a new condo development on Munjoy Hill, a case of Tyvek tape from a Habitat for Humanity restore, marked down to $3.50 because the box was water damaged, 2 cans of Liquid Nails construction adhesive, and a utility knife she already owned. She taped the poly sheeting to the walls, not loosely, not draped. She adhered it with liquid nails in a continuous bead around each sheet's perimeter, overlapped the seams by 6 inches, and sealed every overlap with Tyvek tape. She left a 2-inch gap at the bottom of each sheet, which she folded outward along the floor and weighted down with chunks of broken concrete from the stairwell. That fold is worth pausing on, because that's not something you'd think to do. That's a detail you'd find in a professional waterproofing spec. The gap allows any condensation that forms behind the barrier to drain down the wall, hit the fold, and travel along the floor toward the room's low point instead of pooling behind the sheeting and growing mold. It's called a weep gap. Harlow didn't call it that. She called it giving the water somewhere to go. Same principle. 48 hours later, the walls were dry, and something clicked in Harlow's head after that. She realized the basement wasn't a place she was stuck in. It was a place she could change. So that was the walls. The floor was next, and it was a different kind of problem. The water problem led to the floor problem. The concrete slab in the main room had a visible slope, about 2 inches of fall from the northeast corner to the southwest corner, where a rusted floor drain sat capped with a rubber plug. Water from her boots, from rain dripping off her jacket, from the weep gap, all of it pooled in that southwest corner. Harlow didn't do what most people would have done. Most people would have thrown plywood over the wet spot, maybe stacked some pallets. Harlow leveled the floor. In late November of 2022, she hauled 60-pound bags of self-leveling concrete compound down those 41 steps. One at a time. Over the course of 3 days, she carried 14 bags. She bought them from a building supply outlet in South Portland that sold damaged and returned inventory at steep discounts. $7 a bag, $98 total, which she earned by selling copper wires she'd stripped from an abandoned refrigerator. Self-leveling compound is simple to use in theory. You mix it, you pour it. Gravity does the work. But in practice, it requires a few things that most professionals take for granted. The substrate has to be clean, bone dry, or close to it, primed ideally, with a bonding agent so the new layer adheres to the old. And you need to work fast, because the compound begins to set in about 15 minutes. Harlow didn't have a bonding primer. She scrubbed the floor with a wire brush and a bucket of water mixed with a capful of bleach she'd taken from a laundromat. She let it dry for 2 days with a box fan she'd found in a Goodwill donation bin, running off an extension cord from the construction panel upstairs. She mixed the compound in a 5-gallon bucket with a garden hoe, poured it in sections, let each section cure for 24 hours before pouring the next. It took her 6 days to do what a professional crew would have done in an afternoon. But when she was done, you could set a 4-foot level anywhere on that floor, and the bubble sat dead center. She checked. She'd bought the level at the same outlet for $4. That floor is what Paul Witham noticed first when he came down the stairs 16 months later, before the walls, before the ceiling, before the water system. He looked at the floor and said, out loud, to no one, "Who poured this?" The heat problem came in December. Dry walls and a level floor gave Harlow a room, but you can't live in a room that's 55 degrees. You can exist in it. You can sleep in it if you're wearing everything you own. Eating a meal in 55 degrees, your hands shake too much to hold a fork steady. Harlow needed heat, and she couldn't burn anything, not down there, not 41 feet underground with no ventilation shaft, no chimney, No way to exhaust combustion gases. Carbon monoxide would have killed her in her sleep inside of 2 hours. She knew that. She'd seen a guy named Russ die exactly that way in a camp near Back Cove in the winter of 2021. Propane heater inside a tent. He was 41, same age she was at the time. So fire was out. Electric space heaters were out too, because the construction panel upstairs was a 20-amp circuit shared with whatever else was tapped into it. And she couldn't pull more than about 1,500 watts without tripping the breaker and calling attention to the fact that someone was drawing power from a condemned building. She needed warmth, real warmth, not just better than outside warmth. And she had almost nothing to work with. The solution she came up with is the kind of thing that sounds ridiculous until you see it working. She collected 52 one-gallon plastic jugs, milk jugs, vinegar jugs, distilled water jugs. She filled each one with water and added a quarter cup of rubbing alcohol to lower the freezing point. She painted 30 of them black with spray paint she found in a recycling bin behind an auto body shop on Warren Avenue. She arranged them in a line along the north wall of the main room, 3 rows deep, 2 rows high, stacked in a wooden frame she built from pallet wood. By themselves, the jugs did nothing. Water at 55 degrees doesn't heat a room. But Harlow wasn't using them as heaters. She was using them as batteries. Every morning she'd carry 4 jugs upstairs, set them in the sun on the south-facing concrete wall of the parking garage, and let solar radiation heat the water inside. On a clear December day in Portland, direct sun on a black surface can raise water temperature to 80 or 90 degrees. She'd swap them out every couple of hours, carry the warm ones down, carry the cool ones up. At night, she'd arrange the warmest jugs around her sleeping area. 52 gallons of water at 85 degrees in a sealed room with no air leaks. All of that heat bleeding slowly into the space over 8 or 9 hours. She told a shelter volunteer once that on good days, she'd wake up and the room felt like a car that had been sitting in the sun with the windows up. Warm, in a stale way, but warm. She was running a passive solar thermal storage system. She'd never heard that phrase. She just called it cooking the jugs. But here's what made it work, and this is the part that surprised Witham more than the floor. The jugs were only half the system. This is where it gets interesting, because what Harlow did next is the part most people would never think of. Harlow insulated the ceiling. Not the walls, the ceiling. And there's a reason for that which most people get backwards. Underground, the earth around the walls is your friend. At 41 feet deep, the surrounding soil holds a year-round temperature of about 50 to 52 degrees. That's free heat in the winter and free cooling in the summer. Insulating the walls would have cut her off from it. She'd have been insulating herself inside a cold concrete box instead of letting the earth warm the concrete and the concrete warm the air. But the ceiling was different. The ceiling was the bottom of a parking garage floor slab. Above that slab, open air, wind, rain, snow. In January, the surface temperature of that slab could be 10 or 15 degrees. Cold poured down through that concrete like water through a sieve. Every BTU her water jugs added to the room was bleeding straight up through the ceiling and out into a Portland winter. She needed to cap the room, seal the top. She used 2-inch polyisocyanurate foam board, same material that professional builders use on commercial roof assemblies. R13 per layer. She got it from the same building outlet in South Portland. Sheets with minor cosmetic damage, $2 each. She bought 24 sheets over the course of January 2023. She cut them with a bread knife and adhered them to the ceiling with construction adhesive, staggering the joints so no seam lined up with the seam above or below it. 2 layers, 4 inches of foam, R26 overhead. She sealed every seam with foil tape. The temperature in the main room jumped from 55 degrees to 62 within 3 days. With the water jugs running, she could hold 68 to 70 degrees on a clear day. On overcast days, when the jugs couldn't charge, she dropped to about 60. Still livable, still warm enough to sit without a coat. Paul Witham measured the ceiling assembly when he found it. He said the staggered seams were the detail that got him. "That's a cold bridge break," he told a reporter from the Portland Press-Herald in April 2024. "You learn that in building science class." She figured it out with foam and tape. The humidity problem showed up about a week after the foam went up, because the heat system created a new problem that Harlow had to solve. And the way she solved it is the part of this story that made Witham use the word jealous in that same interview. Warm air in a cold basement means moisture. Not condensation on the walls this time. She'd already solved that. Moisture in the air, humidity. Warm, moist air hitting the one surface she hadn't insulated, the concrete floor, would condense there and make the leveled surface she'd worked so hard on perpetually damp. She needed airflow. Controlled airflow. Not a hole in the wall, because that would let cold air in and defeat the insulation. She needed to move air within the space, circulate it, keep it from sitting still long enough to dump its moisture on the floor. She built a convection loop. On the north wall near the floor, she cut a 6-inch hole through the poly sheeting and the cinder block behind it, into the smaller adjoining room. On the south wall of the main room, near the ceiling, she cut another hole. And in the smaller room, she placed a single 12-volt computer fan powered by a car battery she charged off the construction panel, blowing warm air from the upper hole down to the lower hole. Warm air rises to the ceiling in the main room, gets pushed through the upper hole into the side room. The fan moves it down. It comes back through the lower hole at floor level, cooler now, and rises again as it warms. A complete loop, continuous, silent, almost just the whisper of that little fan spinning. The floor dried within a day, and stayed dry when Witham mapped the airflow pattern with a smoke pencil. He sat on the floor for a while, just looking at it. You'd spec this in a mechanical plan, he said. 2 openings, different heights. One with forced air. She built a dedicated ventilation loop with a computer fan and a car battery. By spring of 2023, Harlow had a warm, dry room with moving air. Most people would have stopped there. She didn't. The parking garage had been connected to city water before it was condemned. The main was cut at the street, but the pipe still ran through the east wall of the basement. Dead pipe. No pressure. No flow. Harlow couldn't reconnect to city water. She knew that. What she could do, and what she did, was build a gravity-fed collection system. At the top of the stairwell, where it opened to the surface, she placed a 30-gallon plastic drum she'd pulled from behind a seafood restaurant on Commercial Street. She ran a garden hose from the drum down the stairwell and through the wall into the basement, where it connected to a Y-splitter she'd bought at a hardware store for $6. One branch of the Y went to a 5-gallon bucket on a shelf, 3 feet above a plastic basin she used as a kitchen sink. The other branch went to a second bucket, rigged with a camping shower head, positioned above a drain channel she'd cut into the floor with a masonry chisel, leading to the original floor drain she'd uncapped. 41 steps of vertical drop gave her about 18 psi of water pressure. That's low for a house, but enough to push water through a garden hose and out a shower head at a reasonable flow. She filled the drum by carrying water up in jugs from a public spigot at Deering Oaks Park, 6 blocks away. 4 trips a day, 2 jugs per trip. 8 gallons, enough for drinking, cooking, and a short shower every other day. The drain worked because the building's sewer connection, unlike the water main, hadn't been capped. Gravity pulled the used water down through the original drain line and into the city sewer system. She tested it by pouring a bucket of water mixed with food coloring down the drain and walking to the nearest manhole cover on Congress Street. Green water. It worked. She had a functional kitchen sink and a shower built from a drum, a garden hose, a camping shower head, a masonry chisel, and 2 5-gallon buckets. The water system would be enough to make the story worth telling, but there's a wall in that basement that changes the whole picture. Harlow divided the basement into 2 rooms. Not by hanging a curtain. She built a wall. A load-bearing wall. She did this for a specific reason that has nothing to do with privacy and everything to do with structural engineering, though she didn't use that word. The ceiling of the basement, the parking garage floor slab above her, was showing signs of deflection. A visible sag in the middle, about 1.5 inches, maybe 2. The parking garage had been condemned partly because of this. The supports on the upper floors had corroded, and the loads were transferring downward unevenly. Harlow could see hairline cracks in the slab directly above the center of the main room. She was afraid the ceiling was going to come down, so she built a wall, running east to west across the middle of the main room, that doubled as a support column. She stacked cinder blocks, dry stacked without mortar for the first 3 courses, then switched to a sand-cement mix she made herself using playground sand from a bag that had split open at a landscape supply yard, and Portland cement she bought at the building outlet. 1 bag, $12. The wall was 8 inches thick, standard CMU block width. She filled the hollow cores of the blocks with her sand-cement mix and dropped in lengths of rebar she'd pulled from the demolished section near the stairwell. Vertical rebar every 16 inches. She grouted the cores solid. The wall ran 14 feet, from the east cinder block wall to a point 4 feet short of the west wall, leaving a doorway. At the top, she shimmed the gap between her wall and the ceiling slab with wooden wedges cut from a 2x4, then filled around the wedges with expanding foam. She built a shoring wall, a temporary structural support to arrest the deflection of a failing concrete slab, the kind of thing you'd see in a demolition contractor's stabilization plan. Witham had the wall tested. He brought a colleague from the Portland office of Wright Pierce Engineering, a woman named Janet Korhonen, who took core samples of the grout and measured the rebar spacing. Korhonen's assessment, which she included in a written report that was later cited in a Portland City Council hearing on homeless shelter alternatives, was that the wall met or exceeded the IRC residential standard for grouted CMU construction. The rebar spacing was within code. The grout strength tested at approximately 2,200 psi, which is below the 2,500 psi minimum for structural masonry, but above the threshold for non-structural partition walls. She was 200 pounds of compressive strength short of code, Korhonen wrote. But the wall is doing what she built it to do. The deflection in the slab has stopped progressing. Harlow didn't know what PSI meant when someone told her this. She asked if it meant the ceiling wasn't going to fall on her. They said no, it probably wasn't. Good, she said. That's why I built it. Here's the part Paul Witham couldn't let go of, the thing he kept circling back to in every interview between April and September of 2024. It wasn't any one piece of what Harlow built. Not the floor, not the vapor barrier, not the jugs or the fan or the shoring wall. It was how they all connected. Everything talked to everything else. The vapor barrier kept the walls dry, which let the earth's warmth come through the concrete, which meant the jugs didn't have to work as hard. The ceiling foam trapped heat in the room so the jugs could actually raise the temperature. The fan loop kept humidity from destroying the foam. The water system ran on gravity and used drain lines that were already in the ground. And the shoring wall, the one that held the ceiling up, also split the space into a warm room and a cooler room, which is the temperature gap that made the fan loop work in the first place. Take any one piece out and 2 or 3 others stop working. Harlow didn't plan it that way on paper. She just kept running into problems, and each fix happened to set up the next one. Whether she understood the whole picture at once or stumbled into it piece by piece, I can't tell you. I don't think she could tell you either. I've shown photos of Harlow's basement to 3 different engineers. Each time, same thing. They go in expecting to be polite about it. Oh, nice, she tried. That kind of energy. Then they see the staggered ceiling seams or the rebar spacing in the wall, and the polite face drops off. They start asking real questions, specific ones, about adhesion methods and thermal offsets, and whether the seam pattern was intentional. She didn't calculate any of it. She tried things, watched what happened, and fixed what went wrong. That's basically what builders have been doing since before anyone wrote a formula down. Trial, failure, adjustment. Repeat. Not glamorous. Slow, but it works when you're paying close enough attention. Janet Korhonen said something in her report that stuck with me. She wrote, "The inhabitant appears to have arrived at correct solutions through iterative problem solving rather than theoretical knowledge. The solutions are not optimal in the engineering sense. They are, in several cases, superior to what I have seen in permitted residential construction because they respond to the actual conditions of the site rather than to generalized code assumptions." That quote sat with me for a while. A licensed structural engineer saying an unpermitted basement built by a woman with no training was, in certain respects, better than houses that passed city inspection. The reason, according to Korhonen, is that Harlow was responding to what was actually happening in front of her. She wasn't building to satisfy a code book written for a hypothetical average house on a hypothetical average lot. She was building for this specific hole in the ground with these specific problems in this specific climate. And it worked. You're probably wondering what happened to Harlow, whether she got arrested, whether they tore it down. She wasn't arrested. Portland's homeless crisis in 2024 was bad enough that the city council had no appetite for criminalizing someone who'd solved her own housing problem without hurting anyone. The parking garage is owned by a holding company based in Massachusetts that hasn't responded to any communication from the city since 2020. The building is in tax lien. Nobody with authority over the property has asked Harlow to leave. Witham wrote a letter to the city's housing authority recommending that Harlow's basement be evaluated as a potential model for below-grade transitional housing. The letter was co-signed by Korhonen and by 2 faculty members from the University of Southern Maine's Environmental Science program who visited the site in June 2024. Nothing has come of it so far. It's sitting in a folder somewhere. Government moves slow. Harlow is still in the basement. She added a bookshelf in September 2024, built from the same pallet wood she used for the water jug rack. She's reading a used copy of Building Science for Building Enclosures by John Straub, which someone left at her doorway, the doorway that isn't really a door, after reading about her in the Press Herald. She's on Chapter 4. She says the math is hard, but the pictures make sense. She told a reporter, "I don't read the way engineers read. I read it and I think, did I already do that? And mostly I did. I just didn't know what it was called." People keep asking what Harlow built. That misses it. She didn't build one thing. She built a chain of fixes, each one setting up the next. She dried the walls first because nothing else works if the walls are wet. Then the floor, because you can't build on a slope. Sealed the ceiling so the heat wouldn't bleed out. Figured out how to store warmth without burning anything. Moved the air so the moisture didn't wreck what she'd already done. Got water running, and when the ceiling started sagging, she held it up. Total cost, if you added it all up, somewhere under $200. And a structural engineer wrote in an official report that parts of it were better than permitted residential construction. The parking garage has been abandoned since 2019. The holding company forgot about it. No one walked down those stairs for 3 years. Harlow looked, and what she saw down there wasn't a hole. It was a sequence she could solve. One layer at a time, one problem under the last, all the way down to the bottom, where the answer had been sitting the whole time, 41 feet below a street full of people who never thought to check. The marble still doesn't roll.